In this video, we're going to practice working a problem finding the mean, median, and mode, and standard deviation. Part of the manufacturing quality control testing for a toy is to measure the depth of a connector piece that must fit into another part. The design depth is 4.1 centimeters. Every 10th part produced on the production line is measured. The following data was collected during a 2-minute production period. See these data points right here. Calculate each of the following measures of central tendency. Show your work. So remember that a measure of central tendency just means that it's showing where the middle of the data points are. So these are 3 different ways that you can find the kind of middle point of all of these values. So one way is to find the mean, or you might be familiar with this known as the average. So the way that we find the average is doing the sum of all the x points divided by the sum of all the x points, I wrote that wrong, divided by the number of points that you have. So if I take my calculator and I add each of these data points together, you can take a second to do that quickly, you'll find that you get 48.8. And then I'm going to divide by however many numbers I added together, which is 12. And when I divide that out on my calculator, I get, let me find my answers, I get 4.06666, some other numbers. So remember, when we're working in, we want to round to one more decimal place than we were given. And so I was given 1 decimal place, so I'm going to answer with 2 decimal places. So the mean is 4.07. Now I'm writing 4.07 for my mean, but what I really need to do when I get to standard deviation is keep all of those digits in my answer so that I can subtract. Next, let's talk about the median. The median is the number that is exactly in the middle of all of the numbers. So I'm going to rearrange these numbers very quickly so that they go from the least to the greatest. Ta-da! And then the median is the number that's exactly in the middle. Now, if we had an odd number of data points, we would have one number that was exactly in the middle. But because we have 12 data points, that means there are 6 on the left and there are 6 on the right. So the median actually occurs right in the middle. Here are 1, 2, 3, 4, 5, 6 points, and then 1, 2, 3, 4, 5, 6 points. There's no actual number that's in the total middle. So how we solve this problem is we add the 2 together, and then we divide by 2 to get the number that's in the middle of those 2. So the median is going to be 4.05. And then mode is the number that has the most, that occurs most frequently. So when I look at these numbers and I see them from least to greatest, I see 3.9 occurs twice, but then I'm noticing that 4.0 occurs 3 times. So here's 1, 2, 3 of these. So that's more than 3.9, so that's my mode. But now I'm noticing there's another one that also occurs 3 times, 4.1. So this means that my mode is bimodal. This set of data is bimodal, meaning it has 2 modes. And so a mode is 4.0, and my other mode is 4.1. And both answers are actually the mode. It is possible that if we had another number that occurred 3 times, that we would be multimodal, and then I would have to give all 3 of those. And if they all occur only once, then you could say that the mode does not exist. Okay, now moving on, let's calculate standard deviation. Okay, so this one, the formula for standard deviation, oh, first, I'm sorry, I get ahead of myself. Range. First, let's find the range. To get the range, you do the maximum number minus the minimum number. We just want to know what's the difference between my largest score and my smallest score. So if I put my numbers back up here in order, my maximum is 4.4 and my minimum is 3.8. Sorry about that. And when I subtract those two, the range is 0.6. These are measures of variation. Mean, median, and mode talk about central tendency, what's happening in the middle of the data. And then range and standard deviation talk about variance, or how much do all of my values vary from this middle number. So the range says this is how much is in between the max and the min. Next, we want to calculate standard deviation. It's another way of variance. This tells me about how far away from the middle numbers are most of my data points. So let's start by writing in our x values. The formula for standard deviation looks like this. This is a lowercase sigma, and it is the square root of the sum of x minus the mean squared divided by n, the total number of points. So we're going to do this in steps. Next, I'm going to do this part of the formula right here. I'm going to take each x value and I'm going to subtract the mean. Now, it's really important here that I do not use my estimated mean or my rounded mean. I need to do 48.8 divided by 12, and I get the mean is 4.066667. So I'm going to do 3.8 minus this number, and I will get $2.6666 repeating. So I don't have room in this chart to write that, so I'm going to write negative 0.2667. And then I'm going to do 3.9 minus my mean. Oh, 4. Sorry, I did the wrong thing. 4.606667. And when I do that, I'm going to have 3.9 minus that number. And then I'm going to get a negative 0.1667. And I'll get it again here. Then I'm going to do 4.0 minus my mean. And I get negative 0.0667. And then I'm going to do, and I'll get that 2 more times. Then I need to do 4.1 minus the mean, all this up here. And when I do that, I'm going to get 0.0333. And I'll get that 3 times. And then I have to do 4.2 minus my value for the mean right up here. And when I do that, I get 0.1333. And then I'm going to do 4.3 minus the mean. And I will get 0.05. Oh, no. 0.2333, and then I'm going to do 4.4 minus that number up there, and I'm going to get 0.3333. Then the next part of the standard deviation formula says after I do the x value minus the mean, then I need to square that number. So I'm going to take each of these numbers here and I am going to square them. So I'm going to use this number and square it, this number and square it. Be sure when you're typing these negative numbers into your calculator and you're trying to square it, that you put the value in parentheses so that that negative gets squared, because then your answer after it's squared should be positive. If you don't, then your calculator won't square the negative and you will get a negative number. And that's just not right. So I'm taking each of these values from the middle column and I am squaring them. In the PowerPoint, you have learned that you should use full values and do not round until the end. But if you'll notice, I am kind of rounding right now. And it's just because I don't have enough room in this chart to write all the different values out. And if I do this squared, I get 0.0544. And if I do this squared, I get 0.1111. So the next part of the step, so now we've subtracted the mean from all the values, then we've squared it. This little sigma right here, this is an uppercase sigma. This E means the sum. Sum all of this. So take all of these numbers and plug them into your calculator and add them up. When you do that, you're going to get 0.3265. Okay? And then the last step is, or two more steps, I'm sorry. Then we've done this part right here. So this equals the sum of x minus mu squared. Now we need to divide by n. So we'll have 0.3265 divided by n, which is 12, because that's how many points we have. And I get 0.027208333. And then my answer says at the very last thing, take the square root. So I need to square root that. And when I do the square root of that number, let me find that on here. I get 0.16494947, and I give one more decimal place than what was given to me, so I need 2 decimal places. My standard deviation is 0.17 centimeters. Notice that this number is kind of small considering we were given numbers like 4.1, 3.8, 4.0. These numbers are in the 4s. This is less than 1/4 of a centimeter. So this means we have a very small amount of variance, and that's how the standard deviation helps you, is these values up here all deviate from the middle or the average by 0.17. So we want to make sure that most of them deviate by less than 0.17 of a centimeter. So this is how we help use statistics to determine quality control in engineering practices. If this number were bigger, like 2 or 3, that would mean we would have a lot more variance in the measurements of our parts, and then we would need to go back to our manufacturing process and try to bring that number down so that we have a more controlled manufacturing of the part. So please stay tuned for our next video where I teach you how to do all of these things using Excel.